Hi, and welcome to accounting. Today we are going to calculate the value of a bond based on its present value and the effective rate. We're working on exercise 14.2 in the Seep, Spiceland, Nelson text. If you don't have the text, the information should be here for you so that you can follow along without the text. So when calculating the price of a long-term bond, what we want to do is we want to calculate the present value based on our effective rate. And there's two pieces to calculating the present value because there's two cash flow pieces. The first cash flow is the principal payment that's received at the end of the maturity. And the second cash flow piece is the interest payments that are received over the life of the bond. And we want to take both cash flows and discount them to their present value to calculate the price that we would be willing to pay for this financial investment compared to others of similar risk. That's our effective rate. Our effective rate we'll take and make sure that they're of similar risk. So the first thing we want to do is take a look at number one. Now, investment number one, or bond number one, has a maturity of 10 years. The interest is being paid annually in this problem. That's a little bit unusual. Most bonds are paid semi-annually, so we'll take a look at how to do that. The stated rate on the bond is 10% and the effective rate is 12%. So we'll get started with calculating the present value of the principal payment, the first piece of the cash flow. So we will take $1 million, which is the face value of the note, and we will have to take and find its present value. What we want to do, if you have the Seep, Spiceland, Nelson text, is go to table 2, which is based on the present value of $1, which really doesn't mean $1, it really just means a single payment. So if you are using a different text, you can probably find this label present value of $1. If you don't have a text, you can also calculate the present value factors using Excel or a calculator. We're going to use the table, so we'll turn to table 2. And what we're going to do is we're going to look in the column labeled NI. NI stands for the number of interest payments. In this problem, we're going to have 10 years where we are paid once a year. So the number of interest periods would be 10. So we're going to take our finger and we're going to go down the column till we get to 10. And then we need to use the effective rate. Whenever you're doing present value calculations, you should always focus on the effective rate. And our effective rate is going to be 12%. We're going to use the whole amount because it's an annual interest rate and we are paid annually. So once we do that, we're going to go from 10 all the way across to 12%. We're going to get 0.32197. So 0.32197 is our factor. Our next step is to multiply the face value times the factor. So we'll take that principal payment times the factor. The next piece is the interest payment. 10 times once a year we will receive an interest payment. The interest payment is based on the stated rate, so that's a little bit different. We have to remember that the company that is selling us investment number one is going to be paying interest based on the stated rate. The way we calculate interest is the face value times rate times time. So our face value is 1 million. Our rate is 10%, it's the stated rate. And time for us is going to be 12 over 12, so it's going to be equal to 12 months over 12 months, or 1. So when we calculate this, we don't even really need the 1, but I'll illustrate it. So our face times rate times time is going to give us 999,999. We're just going to go ahead and say 100,000. I don't know if we're getting something a little funky here, or we could, oh, because I said minus 1 instead of multiplying times 1. Yeah. So that is why, because I had bumped the wrong button there. So we now have 100,000, which is what we're going to receive annually at the end of each year. The company would pay us $100,000 for interest for holding their bond. And what we want to do is find the present value of that stream of payments. So we're going to look at the table 4, which is based on an ordinary annuity. And if you had a table in the back of your textbook, it would probably say present value of an ordinary annuity. Again, you can calculate it with Excel or a calculator. And again, we're going to go to column NI in table 4. We're going to run our finger down to 10, which is our number of interest payments, and across to 12%, which is our effective interest rate, and we're going to find 5.65022. So we're going to type that in. And that is our factor, and we're going to multiply our payment of $100,000 times our factor of 5.65022, and we get $886,992. That represents the price that we would be willing to pay for that bond. So the bond would be discounted, and we should pay $886,992. If they're asking for more than $886,992, it's not a good deal for us based on our effective rate of interest and our present value calculation. All right, let's try number 2. Number 2 is a little bit different because it's semi-annually. We're paying that interest semi-annually. So instead of having 10 interest periods, we're going to have 20. And instead of looking at a 12% effective interest rate, we're going to have to do 6% because it's semi-annual. So we'll divide it by half. So let's calculate our principal payment first. We'll take our $1 million. We'll put it down there. And then we're going to go again to table 2, present value of a lump sum. And we're going to put our finger on the NI for number of periods, but this time we're going to go all the way down to 20 because we're going to be paid 20 times. 10 years, twice a year, 20 times. And then we're going to go over to 6%, which is half of our effective rate. Since that's semi-annual payment, we want to use half. And we find the factor, 0.31180. And then we're going to multiply the principal payment times the factor to find the present value of that payment in the future. That $311,800 is what we think it is worth 10 years from now. And now we're going to do the interest payment. So we need to recalculate the interest payment because it's semi-annually. So we'll receive the money twice a year. So a lot of this stays the same. The face value stays the same. The stated rate stays the same. Time changes. Instead of it being 12/12ths, it'll be 6/12ths because we're going to receive it after only 6 months. So now when we come down here and do the calculation, we're going to say the face value times the stated rate, because that's what they're actually going to pay us, so that represents the cash flow, times time, the 6/12ths, is going to give us $50,000. So that is our interest payment that we would receive twice a year. And now we're going to go to table 4, which is an ordinary annuity, and we're going to find that factor. We're going to put our finger on the NI, the first column, go all the way down to 20 periods for 20 interest payments, and then we're going to find the 6%, the effective interest rate, which is 11.46992. So I'm going to type that in. And then we'll multiply the factor times the cash. And we will find that we have $885,296 is the price that we'd be willing to pay for bond number 2 with the semi-annual interest payments. So if the bond is being offered for $885,296, then that would be a good price for us to pay for it based on our present value calculations and our effective rate of 12%. I hope this helps in your study of exercise 14.2. If you have any questions, please let me know, and I hope you have a great day.